Hey everyone, welcome to this series From Token Spend to Outcomes. This is going to be a serialized conversation for engineering leaders about transitioning from token maxing to outcome maxing in software engineering. Soon we'll do intros and all that, but I just want to center us on the topic first. Today we're going to talk about what does productive AI work actually look like? And let's just face it, it's not easy being an engineering leader today. It's not easy being an engineer either. If you're like the tens of tech organizations that we speak to every week, you're sending your teams three signals at once. Use AI more, don't blow the budget, and show us what it actually produced. And most engineering teams have no way to understand their AI spend or make every token count and run AI at scale with the controls they need to match. So that is what this series is going to be about. Thank you for joining us on our first session. Before we dive in and do some intros, I have just a couple of housekeeping things to go through. The session is being recorded. We'll send the recording and the slides to you after the session, typically within a day. Please also ask your questions at any time. You can use the Q&A function at the bottom of your screen. We'll be monitoring it throughout and answering towards the end or when we can. So now on to introductions. These are pictures of us before AI aged us 10 years. My name is Naomi. I head up product marketing at Faros and I lead our research. I authored two popular reports, the AI Productivity Paradox and the AI Acceleration Whiplash, both longitudinal telemetry-based studies on the impact of AI adoption on engineering outcomes. Acceleration Whiplash, the one we published just a couple of months ago, documented how we're finally starting to see the positive impact of AI at the company level, not just the individual, in the form of more epics, tasks, and code shipped. But we're also seeing an alarming degradation in quality, which is manifesting as increased incident rates, bugs, and churn. And one of the root causes, as Chase will show us today, is due to inefficient AI usage, which can be very unproductive. So, Chase, over to you to introduce yourself.
Thank you, Naomi. Happy to be here. Chase Norton, head of AI here at Faros. Background in entrepreneurship, big tech, startups, everything in between. Originally graduate studies in ML that then had different papers published in the industry, and now focused on how do we take this alien technology that we have, this extremely efficient tool, or at least this tool, and make it efficient for companies and engineers to use. And so that is a passion that I have and look forward to kind of talking about it through this series.
Fantastic. Okay. So today we are talking about productive AI work. The very question implies that there is such a thing as inefficient and wasteful AI work.
Yep.
And if you want to recover inefficient spend, recoup it, redirect it, you need to understand it. So that's what we want to do. We want to demystify what that means for leaders. For the next 5 minutes only, we'll use this old talk show trick. We hit a topic, it goes up on the board. So I'm going to kick us off by talking about the spend is exploding, right? Token spend now routinely exceeds a developer's loaded salary. What started as exciting new tooling has now become a huge capital allocation decision. And leaders are really struggling to justify the spend at this scale and are forced to make some pretty consequential decisions about where the money should come from. One CTO told us that their best engineers spent $47,000 on tokens in a single month, and they had no idea if that's defensible, the new normal, and they need to replicate that across the board, or something deeply concerning. So, Chase, unlike me, you are an engineer and a developer. What's your experience, and what was the highest token bill you've ever seen?
I think I could match the 47 for sure. The My experience has been, I mean, we started in a web browser having a conversation with ChatGPT, and we are now at a point that we have harnesses that are spinning off, 10, 15 agent teams at once. And so it's not just that in some ways the models have gotten more expensive, even though we thought that they were going to get cheaper, but it's also the fact that these harnesses can now spin up and just explode tokens. I have had five-figure days of building out, and The scariest thing, and kind of the thing that we'll talk about and hopefully give some help and solutions to, is a lot of this is still being kind of done in the dark. As you work, the counter is not sitting next to you, letting you know how much your burn is. And so it is very easy with a lot of different foot guns these days to just explode the cost and then hear about it the next day,
Yeah.
as somebody is giving you a call saying what happened, and I've had
Yeah.
that phone call. So
You
yeah.
have. And you also told me that it's very easy to spend $1,200 in 10 minutes. And then you told me that it's also easy to spend $3,000 in 10 minutes.
Yeah.
So it's the same behavior. Like you as a developer didn't change anything. It's just the tools underneath that all of a sudden are applying so much more that drives up the cost.
Right. And I mean, I think at the same time, it's like as these new tools come out, we have 5.6 Sol Ultra that just came out, which loves to, at least in the beginning, they've kind of tampered it down a little bit, but loves to spin up these teams, right? And loves to kind of just like chew through tokens. As these new tools come out, we want to explore them. That's like part of our job is to understand our tooling. And so a part of that will just be is you can realize these foot guns are there where you are exploring, you're trying something out. It's the same process that you've had the week before, but now you just 10x your spend just because of the new additions to a harness, the new workflows that they have. Same thing with Claude, right? As Claude introduced Ultra Code, we all of a sudden had this ability for Claude to combine that with something like Fable, and you have the ability to just blow up your budget and not even realize that you're doing it. And so it's happening on the frontier for sure as they're trying to build out better tooling. It also comes
Yeah.
at a literal cost. Yeah,
Yeah, yeah. Okay. So you're here to argue that there's something to do about that, right? Not all AI token spend is created equal. There are productive and efficient practices, and there are wasteful and inefficient practices that lead to high
absolutely.
token burn. I think you're going to show us also an example, right, of efficient practices that can also result in higher PR quality, which increases the net ROI from your AI token spend because you prevent those bugs, incidents, and rework down the line, the ones that I found in our reporting and our research. So basically, you have a cure for the acceleration whiplash,
I,
which is pretty awesome.
I think so much of right now is having spending like the reps, the time with AI in order to develop the frameworks, the intuitions. And so one of the things that we're going to kind of go through is just this is the framework that for me from 2022, starting within the browser to every single day as I built my companies and I then continued out into helping startups. And then where I am now is every single day, 12 to 18 hours a day, working with AI to try to build how do we make this more efficient? How do we get it to produce the outcomes that we want? Because that's what you care about when it's you and AI all alone and you're trying to build a startup, or it's you and the entire company and you're trying to produce outcomes and move the needle, right? Either way, it's the same thing of I wanted to do what I wanted it to do. And so as we kind of go through this, this is the framework that I built up in my head whenever I approach a problem, whenever I start to interact with AI. I look at it kind of from these 6 points of starting with intelligence allocation, right? This is the easiest foot gun that if you are one month into using AI, you are given a task, you have a bug to solve. The very first thing most people do is they go in, they pick the most expensive model, the most intelligent model, the highest reasoning. Maybe they step it down just a little bit just because they don't want someone to call them for spend. But really, every single action has a different intelligence need, a different effort that can be required to obtain the same output. And so taking a moment for really the intelligence allocation. And we're going to go through each of these in the demo, but this
Yeah,
is the
yeah.
list that we're going to kind of look at here.
Okay. And this is great because um, this is a session, a talk for leaders. So they're not in the coding
Absolutely.
tools day in and day out like you are. Some of
Yep.
them do code and try the tools and so on, but it's not the same thing as this kind of like ongoing experience and exposure that a senior engineer like yourself would have. So what we're trying to do is not teach our audience how to use the tools,
Hmm.
but we want them to understand what makes for a productive and lean and efficient session so that they can, when they're coming back to their teams and having a conversation about the spend, they come in with a like some knowledge about the good practices and they can impart those to their teams and help guide them towards more lean and productive usage. So,
100%. Yeah,
yeah.
100%.
Okay. So, Chase, I'm gonna
Yes.
stop sharing, let you take over
Okay.
and show us through like a real example and your list what these six signals are, and then we'll look at what the results are from using them that way.
Sure, sure. Would you like me to just jump right into the demo here, or was there something else that you'd like me to
Yeah,
jump
no, I
into?
think that's great. Let me tee you off. So you mentioned the first point, intelligence allocation. So
Yep.
first setup, what were you building here? What's the premise of this demo?
Absolutely. So in this demo here, the idea is that very rarely are we starting greenfield. We're often working inside of an existing repo. And so wanted to look at a very, very popular code base called open code. This is kind of what powers a lot of the open source models that this is a harness that does that. And think about it as like Claude Code or Codex. And so looking in this, the idea is let's find an issue that they have and let's go solve their problem, both in an efficient way, or at least according to the framework that has built my career and my brain, and the inefficient way.
Okay.
And so let's approach it from both of those and see what the outcome is, and whether or not the framework is working.
Okay.
So we're looking at an issue here. Essentially, there is a issue opened up of the harness will have an error, have a bug, and then continually loop on that bug over and over again, 277 times. And so the idea is let's dive into it. Let's use both of these kind of frameworks and try to attack it.
Okay.
So looking at like first, we have intelligence allocation. The very first thing that we do is we have that, and then number two is guardrails. The reason I say I combine them together is because at every single step, we're thinking about which model to use. And you can see that here. This
Hmm.
is the models, and we're thinking about what is the effort necessary. The effort is going to increase the number of tokens. The model is going to increase the cost of those tokens, right? And
Okay.
so we want to know how much intelligence do I really need and how much do I need it to think? And if you ever need a mental model for like what does it mean to think, it just means that the AI is essentially asking itself that question in a loop until it finally has some kind of confidence that it's answered that question. That is the only thing that thinking really is, or that's an easy way to explain it. So the
Okay.
first thing that we do is we had a very low intelligence. So we're looking at just came out here Luna, and then the effort was medium in order to set up what we call guardrails, or at least to understand within this code base, what are the guardrails? The guardrails can be things like test, linting, type checks, lines of code. So has like I always put a 600 line of code limit. And the
Mm.
idea here is not to, that it has to be a 90% coverage or anything like that. We are trying to give AI the ability to know that when I modify something here, did I break something over here? I always think about it as like a mesh net that you put over your code to know where things change as you make changes in other parts of the code.
Okay. So is this the
Please.
guardrails that you gave it?
This is me saying, please go explore the code base and
Okay.
understand its guardrails. Is there anything else that we need to set up before I dive into this code base since I've never seen it before?
Okay.
And so it goes through, understands the dependencies that are necessary for it. In this case, it worked for about 2 minutes. You can kind of go through this. But in the end, it determined that the guardrails are there. Test coverage is good, which makes sense for a code base like this. And in general, the guardrails that are there we can use. Now, again, the reason why we used a kind of lesser intelligent model with less reasoning is because really this is like the boilerplate. So you can think, when I'm doing boilerplate work, when I'm doing like kind of setup work, this is where you don't need as much intelligence.
Okay.
Then, and this is kind of where, just like as an example, this run cost 15 cents to do, took about 2 minutes, and the overall stats that we have here. This is where then, okay, so we have the guardrails in place. Having those in place know that whatever we change, we can know where things are, what else is impacted.
Okay,
But
so now
now,
you're moving on to onto signal number three, which is thoughtful implementation planning.
exactly,
Okay.
exactly. Thank you so much for as my brain goes in this direction, Naomi kind of like
Yeah.
helps me go in this direction. So thank you. So moving into the third, this is really one of the most important parts and where the inefficient code will start to kind of reveal itself is most beginner engineers will just jump right into the problem. They'll just say, here's what I want to solve. Go ahead and go. Here's the bug. Instead, everything with AI is about an evolving conversation. It's about sitting down and saying, look, I have an idea as a human that I'm going to give you, but I also want to know back from you what you think. And then we're going to go back and forth and back and forth. And so as we go here, we're going to increase the intelligence. We're going to increase the reasoning because now we're actually going to dive into like, I want to know what you think. And don't worry, I'm putting air quotes on think, but like,
Mhm.
I want to know what you think. And you'll see here. So we presented, this is, go ahead and study the repo, the code base, come back to me. And then I want to know what you think about the code base and the PR, or sorry, and the issue. It then does that. I review what it said, and then I come back and I say, wonderful, but I disagree on some areas and I want more clarification in other areas. Do these concerns change your recommendation? I continually say, do not code. We are having a
Mhm.
conversation, right?
Mhm.
Same thing here. And we go back, I think, 3 times in this
So
case.
I want to ask you a
Um,
question, Chase,
Please.
because somebody could think,
Yeah,
oh my God, this is wasteful. So many turns back and forth
sure.
with the AI. That might just be wasteful. Like, why? And so, I mean, what's the
Yeah.
answer to that? Like, I mean, maybe
So
you have evidence that it's not wasteful at all.
luckily, I do have evidence, but I also have gut intuition. So
Yeah.
again, like so much of where we are right now is yes, we have the evidence, we have the numbers, but it's also building that understanding that context is everything when it comes to AI. And so the more that you can massage the context, create the context, give the space, what I think in my head is like context space, the more that once you go to implementation, the better aligned it's going to be, the less churn it's going to have, the more that it is going to give you what you want on the first pass rather than the 10th pass. And that's exactly where we'll get into with the inefficient is there was no conversation, right? It was just go do it. And the reason why this is rated so poorly and inefficient with high waste is because actually the end result we're going to have to rewrite because it went in a completely different direction, added features we didn't need, and needed a rewrite of the entire architecture. And so it's about this evolving conversation that we have here, this back and forth, me disagreeing, it kind of providing more context to get to the point where finally I say, okay, we're aligned. This is what I want. This is what we need. And also the beautiful thing about like this moment is this is the expansion moment of yourself, of the spec, of the feature, where we come in saying like, I want this, but be open to like the peripheral of what it's providing because it normally has other creative ideas that you can either roll into, fold into your idea, expand, or at the very least say like, interesting, I'll come back to that and try again. This is the learning moment for like most humans as you're having this back and forth to like remove the blinders that you've always had or you built in your career to start to look at things a little different.
Okay.
Um, so
Would you also
soup
say that this is also what makes you not just like a button pusher, go AI, go, but you're actually internalizing the knowledge about the repo, the task at hand, and so on. So this is what allows you to keep that judgment above AI, as opposed to
it,
just giving it black box instructions.
100%. And it's just like this is the fun part, right? Because again, this is the expansion part. You can be like, I've never thought about that library, or what about this architecture? And then you can go a little bit deeper, right? And you know, you mentioned like, can't this become inefficient? Um, if you were to, I guess, like go very, very deep, maybe. But I think, you know, that's where if it's expanding you, if you're learning from it, if it's creating those sparks of creativity or aha, like there's value in that that maybe can't be measured. But also, this is not a time to like use the most expensive soul with extra effort and all that. This is a conversation. You need it to be
Okay.
intelligent enough, but also don't burn through the tokens just trying to get an answer of like, does, you know, should we have caching or whatnot. So
Okay.
that's where right now at this point, Terra is good. Sonnet 5 is good, though the cost on Sonnet 5 have kind of been controversial. But Sonnet, Terra in that range is a good kind of conversational. The only time that I would like put a asterisk here is if you are working multi-repo in a large system. So if you have something like, you know, 20 microservices and you're sitting above the repos, so your AI is looking at all 20 of those, that's where you will definitely want to bump up the effort, give yourself more intelligence because it's having to dive into different areas of large code bases and come back with strong reasoning. So
Okay.
again, it's
Okay.
there is no formula, but think about it as you're going through it. Yep.
Okay. Great. So are you ready for number four, which is definition of done?
I mean, is the audience ready for number four? That's my question. Yeah. So you now have you have your conversation. You now are looking at definition of done. And I think in our industry we know this term really well, but it's also for AI is you want to give it what I call like the verification space or the ability to verify its work. And you want to tell it what that, when it is done doing its work. And so one of the most common is with, and so kind of we went through this. This again is a back and forth conversation. In this case, we use Terra High in order to do this because the idea here is we want to make sure it understands how to stop and we want to it to understand why and the tools that it can use. And so, in something like Codex, for instance, beyond just the prompts that you see here, do not implement, stop, so I can challenge. This is the threshold, define it, blah, blah, blah. Is you can also say things like Chrome, and you can specify the exact tool. So, Chrome, and I don't know if you need calendar, and you can specify and say, create a one-to-one parity with the spec that I have, with the ticket that I have. This works with Linear, it works with Jira and whatnot. And so define it so that it has the ability to measure and verify if it is done, and go back and forth until the understanding between your AI and or your team's AI and you agree. I'm close to accepting this, but here's the points I'd like to tighten. So this is coming from me.
Hmm.
We're continually like getting to that point where we say like we are lock sync. We are completely aligned, right? And
Okay.
so here we go again, the scope, required behavior, regression proof. What do we expect from test? What do we expect from not just clicking around E to E, but also in our test being able to know. And then one final one, right? And so then we finally landed here. This is our definition of done. And the beautiful thing is as you look at kind of 4 and 5, is 4, once you have that understanding of we know what our conversation of what we want is, we know what our definition of done is, when you can stop, how you verify your work, how you can actually say like, okay, this is what the human wants. Then we go into plan mode, loops, goals. If you need agent teams, we go into the topology of the
Okay.
compute. But this
So
is
hold
where
just for
we
a
are now.
second, Chase.
Sure,
We're
sure.
gonna get, but I love like, I'm sure the audience can see that you've inserted these images so we can see how much that exchange cost, right? You're
Yep.
counting each step. And, to my point, oh, I would think such a long exchange and so much back and forth would be inefficient or expensive. Au contraire, it's quite efficient, and it's going to ensure that when you actually move on to execution, the execution is really tight and lean. It,
And,
yeah,
and another way to think about it is like, have you spent 17 cents trying to come up with the definition of done for, like, how many hours have we
yeah,
all spent in a room with our like team being like, all right, we need our definition of done, right? We've all done that. This was 17 cents, right?
amazing.
And
Yeah.
it sets that so every single time you're able to build the definition of done for that task, that feature, and then it knows when to stop. The whole idea here, as like you'll understand this framework that we're kind of going through, is there will come a point where you say, okay, go, right? Where you
Right.
give it autonomy. But that autonomy needs to be bounded, and it needs to be something that you have put the guardrails, you've given it the space in order to succeed. And so that's what we're kind of building to.
Okay,
So
so now
now, go ahead.
two more, right? I'm just going to remind
Yep.
you and give you around 5 minutes to get through them. Compute
Cool. All right.
topology and organizational self-learning. So
Absolutely.
go.
Okay, so once you have definition of done, you have basically everything necessary, whether or not you're in Claude or you're in Codex or you're in some Cursor, you're able to create a plan. And so now you're going to take all of that learning and you're going to distill it down into all the conversations you've had, definition of done, and you're going to distill it down into creating a plan. The reason why this is important is this persists after compacts. This is a way to have a persistent document that allows for AI to refer to. So you take it and you say, okay, now is the time to create a plan using the accepted definition of done, create a formal, plan that we can refer to. It creates the plan. Again, conversation, right? So now we review the plan. We say, before I approve, these are the four issues. Rewrite the plan. It rewrites the plan. You can view it here. And now we're ready to say implement. Now, all
Okay.
of these harnesses have an interesting thing where you create the plan, it saves the plan, you have to say implement, and then you have to stop it if you want to do loops and goals or something more. So now we stop it, and this is where just in building the plan, heads up, the plan does cost, right? This plan costs
Mhm.
$1.64. But this is now the canonical source of this is where you go to say like this is what we will build and how we will build it. Um, and now you go into saying, okay, I'm going to set up a loop in Codex that is called a goal. And you'll see it here this is essentially the goal that we set up, worked for 40 minutes. And what it does is continually just loop and go over both the plan as well as its definition of done, asking itself, have I completed the task according to what our criteria are? And
And
it
is
does
this where
it
you upped the intelligence level? Did you up it to ultra or something here?
wonderful. Yeah. So in this case, for this specific issue, we were able to say, you know what, we're not doing the most complicated solutions here. So we stayed on Terra, but we did bump our effort up to max in this case. And
Okay.
so could have been extra high. I'll have to scroll down, but extra high max. We bumped it up so that there was more effort and thinking as we moved into implementation mode. So goals, plans, loops, all of these, now that you have the space to succeed, these are essentially just looping through all the stuff that we've done to implement the plan. And it went through this for 40 minutes, opened up a PR, and gave us its tokens that it used. There's some caveats there. And now we're done. It has gone through the full list, 1 through 6, and we are done. And we have our cost in order to implement this solution, which, if this number surprises you, this is fairly affordable.
Yeah.
Uh, and yeah, so we kind of go into this.
Okay.
We
So Chase,
yep.
talk about organizational self-learning and then show us the inefficient one so then we can show the audience the comparison between the two.
Love it. Okay. Organizational self-learning throughout every single step of this. You want to be making sure that your AI is aware of when it finds issues and bugs, when it finds gaps in its understanding, that it persists in somewhere. Both Codex and Claude have memory, so persistent into memory, but they also have agents.md or claude.md files that are instructions that are read on basically every turn. And so you want to make sure that this is a self-learning loop. As it fails, it learns, it saves its learnings, and then as it kind of continues, that process just continues to get better and better and better. So as you work with your harnesses, as you work within the repo and the code base, it learns it, it gets better and improves as time goes on. That's really the organizational self-learning combined with as it's implementing it, it's going to understand our plan wasn't exactly correct. We didn't think about this. We don't have buttons installed. As it goes through those and finds those, make sure that it is adding them to ideally agents.md or Claude. Let's jump over into the inefficient. This one's actually going to be
Mhm.
fairly quick. So our inefficient, we came in and we said, like most beginners, and sometimes even just however long you've been using it, you get a bug, you get an issue, you copy it, you put it in, you pray, you feel like you're going to Vegas and you're gambling, maybe it's going to get it right. And so that's what this did. It worked for 40 minutes. This was on Soul Extra High, no, Soul Ultra mode. So it built out a team of agents. Yep, it built out a team of agents in order to solve this. And there was no conversation, no back and forth, no evolution of the problem, the verification space. And what ended up happening is you can see the comparison here. The cost became it opened up a PR. The cost of that of all token usage of all the agents, the agent team, $66 and 37 minutes. And you can kind of see that here.
Yeah.
And this is what we're talking about, right? Is like the difference between just like paste and go, or even if like you skip some of the steps, right? So if you didn't have that definition of done, what happens is it would just continually loop. It would finally stop, but it would be very wasteful as it tried to figure out, am I done? Am I not? And so the framework of, having the conversation, definition of done, creating the plan, then creating the goals, going through that allows for it to be very tight at every single step. Whereas here, it just kind of says like, I'm just going to keep going
Right,
and I'm going to
right.
burn through tokens. Yep.
Okay. So
Yep.
fantastic. Chase, I'm going to take back the screen sharing now. You can stop sharing.
Please.
And and
That
I
was a
want to
lot.
show, so what I'm going to do is um so for anyone, this just to remind the steps that we went through, and let's put those two results side by side. Okay? What jumped out at me, I mean, this is one task, right? We see almost, 5x difference in the cost. But what really struck me is also the quality. The quality is so much better. So we got like higher quality for lower cost when we used this framework. Same repo, same issue, as you say here. Um, what what jumps out at you when you look at this that might not be obvious to me?
I I mean honestly the cost is kind of expected, right? Whenever you're using the especially Soul Ultra.
Yeah.
But I think what's nice is as you go through step by step, you seeing the PR quality be significantly higher, 35 points higher. But also the number that isn't here, but it's kind of hard to capture is I know every step of the work, right?
Mm.
I can go in and I can have a conversation with about this with my other engineers, my team. Whereas the one on the right, not only did it cost more, but we're completely ignorant. So now, how do we go in and talk about it? How do we evolve it? And so I think it's the numbers are great. I don't want to say surprising, but they're great. But it's also just like the side effects of being able to mentally map to every change that your AI did, just
Yeah.
very powerful. Yeah.
Yeah, I agree. Okay, that's amazing. Okay, so now, before we transition to the Q&A, I'm going to ask you one short question. If all these six signals look healthy, have we proven business value?
No.
Oh no.
No.
Yeah.
Yeah, there is a story that is told beyond just was this efficient? And that story is like, did the work that AI put in, did the spend the investment that we put into AI, did it move the needle in the company? Right. And I think this is the question a lot of people are asking. It's kind of twofold, looking at like what we just talked about, but also looking forward of what are the outcomes? Did it ship? Does it align with our initiatives? How do we measure that? That whole story. And that we
Right.
did not answer in this right
Well, we
now.
did not answer it. That's a whole other conversation. That's what we're talking about in our next session. So that's the second part of this
Oh,
puzzle. And
nice.
we invite everyone attending right now to join us next time when we take it to that next level. So now we are going to transition to Q&A. Chase, put your eyes on the Q&A tab if you can. In the meantime, I'm going to tee up one great question that I loved over here. Um,
Hmm.
One is that, when we're looking at the different intelligence levels and choosing the right model and the effort, there's a lot of talk nowadays about whether a open source model can accomplish the same thing as a frontier model, but for cheaper. And that also helps to reduce token spend. So, what do you know about that?
I know that we are at a wonderful time to ask that question.
Really?
It's never
Yeah.
been able to be answered in like a yes until recently, right? And finally, we're at a point where models like GLM 5.2, Kimi 2.7, your harnesses like open code that we were just working in, we are finally coming to a point where it is possible to compete at the frontier. We even had one of our field CTO, Ron, he wrote a great blog on this of showing that not only is it competing, but it's outperforming frontier models and frontier harnesses in some of the measurements. And so we are at a point now where open source is possible to compete. It's possible to consider. It's still kind of a lot to host, and so there's great providers for that. But we are moving in the direction that I think we all want, where we own our intelligence. We are part of that ownership at the very least. And so it's a great time to kind of experiment if you haven't yet between Frontier, your Anthropic, your OpenAI, and your open source that is now kind of there to provide similar, if not better, output right now. So it's
Okay.
the answer is yes, and that
Yeah.
surprises me. A few months
Yeah.
ago, even a year ago, the answer was absolutely not. And I
Yeah.
don't know if you heard, but Apple also is now like, I think their M7 chip is now looking at 1.7 terabytes of being able of memory, and it's like the direction is moving perhaps on device faster than we even thought. So it's the next couple of years are just going to be wild. Yeah.
Okay. Fantastic. Yeah. I think in Ron's study, he found that for specific tasks, he could use one of the open source models and accomplish it at the same quality for half the cost. Like maybe you burn more tokens, but
Hmm.
you get eventually to the half the cost. So that's good. Um, so Chase, take a look at the Q&A.
Yeah,
David is
yeah.
asking if you've ever tried OpenSpec for
I
guardrails.
have.
Yeah.
Yeah, it's whenever we're looking at helping people to get started, I am a huge fan. OpenSpec is a great way to kind of get started to provide the guardrails out of the box. I think as you gain the intuition, you'll drop some, you'll improve on it, but any way that we can help people to get started, especially with guardrails, because they're so important to just like keep the model moving in a direction that doesn't introduce more bugs, more code. I'm a huge fan for. Yeah.
Okay, fantastic. And then one cool thing Robert is asking is how
Hmm.
can developers become more self-aware of inefficient practices? You were showing us how you were counting tokens as you went.
Hmm.
Are there things that leaders can bring back to their teams to do that?
Yes, there is. Actually, in order to measure this session, built out this little open source, or at least it's available for the public, tool and Monet, and this allows for you to monitor in real time as your, excuse me, as your session is going on. It also has different floating meters and whatnot so that you can bring it in. And as you are working with AI, it will give you your current burn rate in dollars. And I can tell you there's nothing better than me watching going from let's say Luna into Terra, watching my burn rate go to $20 an hour, $100 an hour. Sometimes if I'm working in Fable, $200 an hour. The
Yeah.
more that we can be aware, and I know right now we're seeing kind of like a Mac app, but there's these floating, let me see if I can also just share it, but there's these floating little
Oh, I can
meters
start.
that you can put into Codex, put into Claude that we've created in order to just keep that visible at all times. And the more that you do that, the more you get the intuition of like, if I increase this, my burn goes to $75 an hour. And I just think we're at a point now that more awareness is good. And so, yeah, this was built to kind of create for this demo. And let me stop sharing. But yeah, that's what I would
Okay.
recommend. We have a link to it for the GitHub repo, Mac native, and you can just install it and start monitoring.
Okay.
It also has a local inference so that it can monitor are your current sessions productive, wasteful, and it's able to analyze those sessions. Everything stays on device, nothing goes to the cloud. And so you can get all that helpful feedback from AI while keeping it all local. So
Okay.
cool.
Fantastic. Okay. So for leaders, you have a framework. Now you also have a tool that you can give to your developers so that
Hmm.
they can see it live and kind of internalize these good practices. So we only
Yep.
have like 3 minutes left, and I have some final things to go through. There's a question from Alfonso. If you want to take a look at that while I wrap up, you might be able to type him an answer, or if we have time, you can tell me if we want to answer it live. In the meantime, for those in attendance, I want to give you a couple of resources. So one, I referenced the AI acceleration whiplash report. We have a QR code here. You can scan it. That'll tell you about why it's so important to become more efficient and productive with your AI code because the downstream impacts are basically washing away the gains. So grab that there. And also, there's a guide here, a framework for making decisions around token spend in the form of measuring token efficiency. So this guide is meant to be like an antidote to the whiplash until you get all this under control. It provides 3 outcome metrics and 11 guardrail metrics to ensure you see the ROI from your AI investment. For anyone attending this session, it will be very familiar, but it's really for leaders if you got to get a handle and make some decisions about what you're doing next with AI. This field guide will help you at least identify the metrics and what you need to instrument in order to make those decisions.
Love it.
And we'd also like to invite you to join our upcoming Tech Talk, where you can see a live demo of an enterprise solution for getting visibility into your token spend, your token efficiency, and the outcomes it's producing. So today we saw through the lens of one task and one developer, Chase,
Mhm.
what that looked like. But as if you're managing an organization with tens, hundreds, thousands, or tens of thousands of employees, the problem's at a different scale, and you need to see that at a higher level without
Mhm.
losing the granularity to fix things at the core. So that's what we're going to be talking about in this Tech Talk. We'd like to invite you to that. Chase, do you want to answer Alfonso's
I
question
would
live?
love to, just
Okay,
because
go
the
for
reason
it.
you're all
So,
here is to ask questions
so
for
restate the
sure.
question for the audience, please.
Yes. So let's answer it live. The question basically is should we have a conversation with our plan or to avoid context rot? The idea there is can we bloat the context to a point that the models become worse? My opinion is try to stay in the context as much as possible these days. The models are able to work around it, work with it. Compaction has gotten much better. Even in 5.6, it's even improved. So my opinion a year ago would have been yes, go into a new plan, avoid the context rot. Nowadays, try to stay in it. Just let that compact happen, and good things will also flow. So stay in it.
Amazing. Okay. Right on time. Thank you, Chase.
Woo!
Thank you, audience. We'll see you next time.
Thanks, everybody.